Okay guys, so in this video we're going to be talking about properties of functions. So basically properties of functions, specifically targeting the graphs of functions. So if they give you a graph of a function, can you specify certain intervals or certain spots, certain sections where the function does specific things? And this is basically the main things that you're going to be going through when it comes to properties of functions. So they might ask you the domain. If you remember, the domain stands for the input or the x values. So the domain input in in, right, where the function increases. I can't spoke right now. I can't speakles. So domain where the function increases, decreases, or remains constant. So we have, this is, in case you forgot how to do that, we read a graph like a book from left to right. If you notice, this graph is increasing from left to right, right? We read graphs the way we read books. Constant, it's flat, it doesn't go up or down, and decreasing, it goes down from left to right. So basically, you're going to have to determine the domain or the input, the values of x, where the function goes up, down, or is flat, constant. Okay. They might also ask you if there is a maximum or a minimum point for a specific function, and what that means is basically if you're thinking about like a hump, the top of a hill, that would be the maximum point. It could also be the bottom of a hill, or it could be the bottom of a peak. It doesn't have to be rounded. It could be jagged like that. It could be like a sharp edge. So this is also a minimum point. This is an example of a minimum point. This is an example of a maximum point. Now, if the graph goes on forever and ever and ever, you really can't find the maximum point because it goes on forever and ever upwards. So you would just say that there's none. If the graph goes on down forever and ever and ever, then you can't really find the minimum point. However, if there is any sort of curvature, we call this concavity in math, but basically if it curves up or down, if it pivots and you have a little point, basically that would be a minimum point or a maximum point depending on whether it's going curving up or curving down. And then we'll do some examples right now to explain what it is that I'm talking about. Okay, the other thing that I might ask you guys is the rate of change. So what is the rate of change? The rate of change is just a fancy way of saying slope. Remember, slope is rise over run. So the slope is an approximation of the slope, or the rate of change is an approximation of the slope over an interval. So if they ask you for the average rate of change, they basically are just asking you for the slope. Now, this average rate of change formula is this one. So slope is equal to rise over run, which is how much do you go up or down, how much do you go over to the right. I like to keep it as to the right, that way it avoids confusion. So how much do you go up or down? Positive means you go up, negative means you go down, and then how much do you go over to the right? Okay, without further ado, let's do some examples. Let's jump into write some examples, and then we'll go over the properties of these functions here. So I have 4 examples, 1, 2, 3, and 4. Now, if you remember, we read these graphs from left to right. So for example number 1, this graph looks like it starts here at the -2, at x equals -2. It goes up, it hits here, and then it starts going down. So starting at the -2, goes up, hits the maximum point, goes back down, and then it stops here at the +2. Okay, example 2. This guy starts at the -3 on the x-axis. Again, domain, right? The x-axis, never the y. So we start at the -3. This guy starts up here. It goes down, it stays flat or constant, and then it goes down some more. And then here at this value, it starts going up. Okay, so from left to right, example number 3, notice the arrows. This thing goes forever and ever down to the left, and then it goes up from left to right, it goes down, and then it goes up again. Example number 4, this thing starts here at the -3, it goes down, and then it spikes up, and then it goes forever and ever that way. Now, let's look at some information about the graph that will basically give information to whoever is reading this basically interpretation of the graph. It'll give them a lot of information in regards to it. And they could actually try to reproduce it if they really wanted to. So let's find the domain. We're looking at domain where the function does a couple of things. So for all these examples, I've been saying the word domain a lot. Domain is actually the input. So I'm going to go ahead and highlight these numbers here, these values, for every single one of my examples, because we're going to be paying close attention to the domain or the x-axis, the x values, where the function does all these things that we want it to do, okay, that they're asking for us to figure out. So, okay, if we look at the first one, what is the domain where the function goes up or increases? Well, the domain is the x-axis. From where to where does it go up, basically? What is the interval? So it starts going up here. This is the beginning of the graph at -2, and then it goes up, and then it stops going up here. But again, I'm looking at the x-axis, so this actually stops going up here at the value of 0. So my domain, my x values where it goes up is from -2 to 0. So I'm going to write -2, comma 0. I don't have any open circles, so it's safe to write the brackets there because we have all the numbers that are included. That being said, there could be the possibility of it going up more than once. In this case, it doesn't go up besides at the beginning, so we're good. Decreases, where does it go down? So if you look at the graph, this is like the highest point, and then it starts going down. It starts at 0. Again, we're looking at the domain, so only the x's. It starts at 0, and then it stops going down here at the x equals 2. So if I follow my peak, this thing starts going down here at the 0, and then it ends going down at the 2. So we're going to say that it decreases from 0 to 2. Okay. Constant, is this graph ever flat? No, it's not. So I'm just going to write never. It's never flat. It's never constant. Is there a maximum point? Is there a peak? It looks like there is, right? So that maximum point is actually up here. If I were to graph that point, again, it's a point. So we want two numbers, an x and a y. If I were to graph this point, it's 0, 2. So my maximum point will be 0, +2, which is corresponding to that point right there. Is there a minimum point? Well, do we have the bottom of a peak anywhere? No, not really. I know you guys are thinking that, hey, these 2 points are at the bottom, but try to concentrate on whether it curves up or down and we have peaks or humps, if you will. That would be considered maximum minimum points. So for the minimum point, you could write none. Some of you guys may want to try to write that there are 2. And in that case, I wouldn't mark it wrong because you actually are technically correct. So if you would like to write -2, -1, which is this point, and it's also tied with this one, which is +2, -1, I would say that those two could be considered the lowest point. So I wouldn't even mark that wrong. But if you just write none and concentrate on the peaks, again, where it curves up or down, then you should be fine. Okay, lastly, rate of change in interval -2 to 0. So from -2, again, we're looking at the x-axis, so -2 is right here. So that's where I'm starting from. And then all the way up to 0. So if I go to the 0, my graph is up there. So all they're saying right there is, if you have your graph from x equals -2, which is right there at that point, to x equals 0, which is the graph is way up there, what is my rate of change? What is my slope? So you have to figure out how much do you go up, how much do you go over. So by looking at this graph goes up that many squares and over to the right that many squares. In this case, it's up 1, 2, 3, and then over 1, 2. Since you went up, it's positive. So the slope is +3 over 2. And that'll be my rate of change in the interval -2 to 0. Okay. They could have asked us for any other interval, but in terms of this example, we could just leave it at that. All right, example number 2, real quick. So for example number 2, where's the domain where the function goes up or increases? Now, if you remember, this thing, we read it from left to right, so it goes down, stays flat, goes down. The only little spot where it increases is x equals 2 to x equals 3. So on the x-axis, so from 2 to 3, it goes up. Where does this graph go down or decrease? Well, this graph decreases several spots. It decreases from the beginning to here. So I'm going to say that it goes down from -3 all the way to -1. So -3 to -1. But not only there, right? It also goes down from here to there. But we're looking at the x-axis, so that'll be from x equals 1 to x equals 2. So we're going to say that it goes down. So, and from 1 to 2. So it could go up or down more than one time. So don't think that you're going to have only one answer for this. Depending on your graph, it might be more than one answer. Is this graph ever flat or constant? Well, yes, it is. It's actually constant from here to there, which is from x equals -1 to x equals 1. So we're going to say from -1 to 1. Do we have a maximum point? Think of peaks, right? So not really. You could say that there's no peaks, but if you want to think of this as your maximum point, I guess you could technically write this as -3, 3. I would consider that correct because technically it is the highest point on the graph. But if you write none, I'll be okay with it as well. Do we have a minimum point? Do we have a peak at the bottom? Well, yes, we do. This is actually that point right there, right? That's the lowest point. If you were to graph that point, it's 2 to the right and then down 2. So 2 to the right, down 2, which is 2 comma -2. Okay, the rate of change in interval 1 to 2. So basically the slope, right? Rate of change is just a fancy way of saying slope. From 1 to 2. So x equals 1 is right there. If I follow my graph, it's going to be here at this point. And then x equals 2 is right there. If I follow my graph, it's going to be here at this point. So what they're actually asking is, what is the slope from this point to that point? Right? So what's the slope or rate of change from there to there? So how much do you go up or down? In this case, we're going down, right, first. And how much do you go over? In this case, we're going over that much. So if we count the number of squares, that's down 1, 2, 3. And then over to the right. So make this nice and dark. Down 3 and over to the right 1. So my rate of change is basically -3 over 1. Or just -3 if you want to write it as your final answer simplified. Okay, so starting it here at x equals 1 to x equals 2 on the domain. So from that point to that point on the function, you go down 3 to the right 1. Okay, example 3. 2 more, just so we're 100% clear on this, because a lot of people usually have difficulty on this. It's a lot for people to process, and they usually ask me a lot of questions on this. So the more examples we have, the better. So where does this graph increase or go up? Now notice that this guy has actually arrows, right? Arrows means infinity. Means that it goes down and to the left forever. So this thing starts going down and to the left forever. It goes up, and then it goes down, and then it goes up and to the right forever. So where does this graph go up? Well, it goes up more than once. First, it starts going up, starting at -infinity, and then it ends at -2. So from -infinity, because the arrow means forever and never to the left, all the way to -2, it goes up. So we're going to write -infinity to -2. That's when it goes up. Okay. And we're not done there, right? So it actually goes up again. It starts going up from here to there, and it goes forever and ever upwards. So we're going to say that this also goes up from here, x equals 0, all the way to forever and ever to the right, so infinity. So we're going to write 0 to infinity. Sorry, I hope that's easy to see. So from -infinity to -2, this thing goes up, but also from 0, which is right here, to infinity, it goes up on the x-axis. So again, I highlighted the x-axis for that reason. Where does this graph go down or decrease? Well, this thing decreases from there to there, right? On the x-axis, that would be the value of -2, and then it ends at this value of x, which is 0. So from -2 to 0, this thing goes down. Is this graph ever constant or flat? No, it is not. This graph is never flat. Does it have a maximum point? Yeah, it does. If you think about the hump, the little place where it like turns or concaves, this actually is the highest point. I know this graph goes on forever and ever upwards, so that's why you don't have to worry about giving the highest point, but if you give the point where it turns, where there's a hump, you'll be fine. So -2 comma +2. That'll be the point where it's the maximum. Minimum point. The minimum point is right there. We can say that it's 0, -1, if we were to graph that. Rate of change in interval -2 to 0. So starting at x equals -2, so look for the function that's up there. At x equals 0, that's right there. Look for the function that's where it is on the graph. So what they're actually asking you is, what is your slope? What is your rate of change from there to there? So from left to right. So from this point to that point, I have to go down first and then over a certain amount. So I have to go down 1, 2, 3, so -3, and then over to the right, 1, 2, 2. So my slope for this example is down 3 over 2. So there is my slope for this particular interval. Again, they can give you different intervals. Depending on the interval, it's going to be a different slope. All right, last example. So example number 4. Let's analyze this graph real quick. So where does this graph go up or increase? This graph goes up starting here at the -1, and then the little arrow says that it never stops increasing, so it goes forever and ever to the right. So I'm going to leave it as starting at -1, all the way to forever and ever to the right. So infinite. So starting at -1, it goes up all the way to the right, forever and ever. Where does this graph go down? Well, it only goes down from here to there. But if we look at that on the x-axis, that's going to be from x equals -3 to x equals -1. So from -3 to -1, this graph goes down. Is this graph ever constant or flat? No, it is not. So we're going to say that this is never constant or flat. Does this graph have a maximum point? Well, no, not really. So it doesn't. There's really no points in which there's like a hump or like a peak, right? So we could just say none for that. Is there a minimum point? Well, it looks like there is right here, right? So it kind of concaves. It starts going down and then it goes up again. So this is the minimum point for this particular graph. If we were to graph that, that's going to be at -1, 0. And finally, the rate of change in interval -3, 2. So x equals -3 to x equals 2. So this one is interesting because -3, the graph is right here. 2, the graph is right there. All they're doing is they're asking you, what is the slope from this point to this point, from left to right? So again, they can ask you any point on the graph, any 2 points that they want, and the average rate of change will change accordingly depending on that. So to get from this point to this point, from left to right, I have to go down and then over a certain amount, right? So if I count spaces, that means I got to go down 1 or -1 and then over to the right 1, 2, 3, 4, 5. So my rate of change for this particular graph is down 1 over 5, or I can write it as -1 over 5. Okay. I hope this video was helpful to you guys. I'll see you guys in the next one. If you have any other questions, you can let me know in class.